Hello, Algebra 1 students. Today we're going to be going over the Unit 7 review. So what I want you to do is go through the review first before watching the video and see what you can complete. And then just come back to this video and watch it and to check your answers and to make sure you got a full understanding. I also want to point out that you should be doing this video after you've completed the rest of the packet. So the rest of the packet should be 100% complete before starting the review. Okay, well, with that, let me go ahead and share my screen and we can go ahead and get started. So the review starts on page 67. So go ahead and hopefully you're there already. And question 1. Graph and label the following two functions on the same coordinate plane and explain in your own words the most unique difference between each of the graphs. Okay, so basically we just want to graph these two functions here. And it already says here the first one is a linear function, so it should produce a line when we graph it. It's linear. And then the second function is quadratic, so it should produce a parabola, which is like a U-shaped. All right, well, let's start with the line. So you can see it's y equals 3x plus 1. Now, hopefully you remember that the equation for a line, the slope-intercept form, which is what this form is, looks like this, y equals mx plus b, where b is the y-intercept. So whatever number's at the end here, in this case 1, that's your y-intercept. And the m, that's the slope. So in our case, the slope is going to be 3. So that's your slope. So whatever number is the coefficient next to the x there, that's your slope. Okay. So let's go ahead and graph that now. So our y-intercept is 1 in our case. So our y-intercept is 1. So on the y-axis, we're going to put a point at 1. Now from there, we're going to use the slope to help us draw the rest of the line. So our slope is 3. So our slope is 3. And we could think of that as 3 over 1. So remember, with the slope, it's the rise over run. So from here, we're going to rise 3, run 1. So from this y-intercept, we're going to rise 3, 1, 2, 3, and run 1. And you can continue on in that pattern, rising 3, 1, 2, 3, and run 1. And you should see that these points all line up with each other, which makes sense because it should produce a line. Now then use a straight edge to connect the points into a straight line. And then that's your graph. Okay. Now we might want to label that this is the graph here. So this is the linear function. Maybe I'll just put I'll just put the equation here. Y equals 3x plus 1. Okay. So you know that this graph goes to this equation. Now let's go ahead and do the other equation. So y equals x squared plus 2. Now again, whatever number is added to the end, that tells you the y-intercept. So notice it doesn't have an x attached to it. That's your y-intercept. So in our case, that's going to be 2. So we know it's going to cross the y-axis at 2. And then from there, one thing we can do is kind of like the simplest version of how to do this. We could always just use an XY chart. Okay. And what I'll do is let's just use some points. So we'll say -2, -1, 0, 1, and 2. So what you would do is we're going to plug in each of these x coordinates into the function and figure out what the corresponding y coordinate is. So for example, if I replace the x with -2, so this will be -2 squared plus 2. So I'm going to replace the x with -2. So again, the function is x squared, so that's going to be -2 squared. And then a plus 2 at the end of it. Okay, so -2 squared, that means -2 times -2. Well, that's 4. 4 plus 2 is 6. So that means we'll have a coordinate point for this function negative 2, comma 6. So negative 2 on the x and positive 6 on the y. So we know that this point right here, negative 2, comma 6, will be a point on the parabola, a point on the graph. Let's similarly plug in negative 1. So y equals negative 1 squared plus 2. So negative 1 squared, that means negative 1 times negative 1, that's positive 1, plus 2, that's 3. So negative 1, comma 3. Okay, right there. We could plug in 0. This one I could just maybe do in my head. What's 0 squared? Well, that's 0. 0 plus 2 is 2. And we already had that point, right? 0, comma 2, we already graphed that. That's the y-intercept. Okay. I want you to go ahead and finish up these other two numbers, plugging in 1 into the equation, figure out the y-coordinate, plug in 2 into the equation, find the y-coordinate. But you should see, once you've graphed all the points, you should see a parabola, kind of like so. Okay. My graph is not the best. Hopefully your picture looks better, but that's basically what it should look like. Now, now in these explanation here, we want to explain the most unique difference between each pair of graphs. So we want to explain what's the main difference between these two graphs. So in this explanation, what I want you to basically say is that the first graph is a linear function, and the second graph is a quadratic. So the first graph produces a line, and the second graph produces a parabola. All right? So I just explained that there, and I want you to explain it here in your own words. Okay? If you need to, you could always pause the video or rewind and hear that explanation again. Let's move on. Number 2 is basically the same question. We just have two different equations here. So here we have y equals x squared and y equals negative x squared. Now, hopefully you know that both of these, since they have x squared as their highest power, both of these will produce parabolas. Just like the one we did up here, x squared was its highest power, so that produced this second equation produced a parabola. So both of these will both be parabolas. Okay. Now, if you want, you could always do an xy chart like we did for the parabola in question 1, and we could just put some points here. So maybe I'll use the same points. So this one is going to be for the y equals x squared. So basically, whatever value for x, I'm just going to square it, and that'll give me my y. So negative 2 squared, that gives me 4, right? Because that's negative 2 times negative 2. Negative 1 squared, that means negative 1 times negative 1. That's positive 1 now as the y value. Okay, go ahead and figure out the rest of these. And then over here, so pause the video and go and finish the rest of this chart. And then over here, we want to do the same, but for the negative x squared. So let's go ahead and do that. Y equals negative x squared. So, and we'll just go ahead and use the same points we did over here, the same x values anyway. So negative 2, negative 1, 0, 1, and 2. So for this one, keep in mind that notice it says negative x squared. That negative does not get squared here. The x gets squared, and then we're going to put the negative at the end. So like when I plug in negative 2, it would be like y equals, and then there's a negative in front of whatever's getting squared. So negative and then negative 2 squared. I know it's a little bit tricky, but we have that negative there. But the first thing you want to do is you want to square first. So don't like distribute these negatives and call that a positive. Don't do that. What you want to do is square this first, and then whatever answer we get is going to be negative of that. So negative 2 squared, that makes negative 2 times negative 2. That's 4. So that's negative 4. So this makes 4, right? But this negative makes it negative 4. Okay, so that's -4 there. What about if I plug in -1? Well, that would be -1 squared. That's +1, but then that negative in front makes it a -1. Okay. 0, well, that's going to be 0 because 0 squared is 0, and -0 is just, well, there is no -0, it's just 0. Similarly, plugging in 1 squared is 1, but let's make it negative. And this will be -4 here. Okay. Hopefully you finish this one over here as well. This one would have 0, 1, and then 4. Let's go ahead and graph both of them. So first, let's graph the y equals x squared. So we have 0, comma 0 is 1 point. And we have -1, comma 1, -1, comma 1, -2, comma 4, -2, comma 1, 2, 3, 4. Similarly, on the right side here, we have 1, comma 1, and then 2, comma 4. Okay, you should see it's the answer, the graph should be symmetric around the y-axis, right? It should be same on both sides, like a mirror image. That's what symmetry means. So our parabola, at least for the first one, will be a parabola going up just like this, a U-shaped. Okay, and again, this is the y equals x squared here. Let's go ahead and label that. Pretty much everything I write, you should be writing, as well as anything I tell you to write, you should be writing. Okay. Now let's go ahead and graph the other one. So 0, comma 0, again, they share that point, right? They both have 0, comma 0. But this one has -1, comma -1. So -1, -1. And -2, -4. Okay. And then +1, -1. And then +2, -4. And graph that parabola. This parabola is a parabola going downwards, just like that. So this would be y equals -x squared here. Okay. Now, here in the explanation, they want you to put the main difference between these two graphs. So here you would just explain that these two graphs, the y equals x squared is a parabola going upwards, while the y equals -x squared is a parabola going downwards. So just explain that there. I also want to point out that generally speaking, whenever you're graphing a parabola, if there's a negative, if the x squared part of the equation is negative, then the parabola will be going down. Whereas if the x squared part is positive, it'll be a parabola going up. Okay? And that's true for any parabola. Okay. Question 3. For the graph of y equals x squared on page 68, that's the one we just did, y equals x squared. The coordinate for both the vertex and the x-intercept is 0, comma 0. Using the patterns you learned in this unit, what would be the vertex of the quadratic function y equals negative x squared minus 3? So notice it has that negative in front. I would like to distribute that negative here. So that would be negative x squared plus 3. Now it asks about, I just distributed that negative like that. Okay. Now it asks about the vertex of this equation. Now the vertex, whenever you have a parabola, and I'll look at these two parabolas here, the vertex is the point at the bottom of the U. Or if it's going like down, it's the top, right? So the vertex is, if the parabola is going like this, the vertex is the lowest point. But if the parabola is going downwards, then the vertex is the highest point, okay? All right, but basically it's just the point where the parabola goes going one way to going the other way. All right, so what's the vertex for this one? Well, one thing you could try to do is you could try to graph it and then just find where the vertex would be. But you should be able to see that this vertex, notice it has a negative x squared. So that's similar to this negative x squared here, but it has a +3 there. So what that +3 would do to the graph is that would shift the graph up. That would shift the graph up. So regular x squared, so regular negative x squared, this one, y equals negative x squared. This one has a vertex at 0, 0, right? But if I add that 3, what that does is it shifts the vertex and the entire graph up 3. All right, so this vertex, instead of being at 0, 0, that vertex position would shift up by 3 as well. So for this function, the vertex would be at, so the vertex for this function would be at 0, 3. Again, just shifting the function up 3. When you move it up or down, that changes the y value, not the x. Shifting it left or right, that would change the x value. Okay, so the vertex is at 0, 3. And I want you to give a brief explanation there. So just like I explained already, that this +3 would shift the graph up by 3, and that changes its vertex from 0, 0 to 0, 3. Okay, so a brief explanation there, just an explanation in a complete sentence, just like I gave you. Okay, if you need to pause or rewind the video to write that explanation, go ahead and do that there. Okay, use the quadratic formula in this unit to determine the x-intercepts, or in other words, the roots of the function. Y equals x squared minus 10x plus 21. So it asks us to use the quadratic formula, which hopefully you remember that formula. It's going to be a very important formula. You're going to be using it not just in this unit, but in units to come, and as well as throughout Algebra 2. So you're going to need to know this function basically throughout the rest of your math career. So, but I'm going to go ahead and write the function over here, or not the function, the formula. And it looks like this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I know it's complicated, or it looks complicated, but it's not too bad. Okay. When you see, by the way, when you see letters up against each other like that, that means they're multiplied. So negative 4ac, that means negative 4 times the value of a times the value of c. Or like down here where it says 2 times a, that's what that means. 2a means 2 times a, okay? Now, what's the value of a, b, and c? Well, those come from the equation that they're giving you. In our case, the a is whatever's in front of the x squared. So in this one's case, the a is, well, it doesn't look like there's anything in front of the x squared. Well, there's like an invisible 1. So the coefficient of this x squared is 1. So that's going to be our a. Our b is whatever's in front of the x. So the coefficient of the x term, that's our b. So in our case, the b is negative 10. You see there's a negative 10 in front of the x here. And the c is the constant. So whatever number is at the end that doesn't have an x attached to it, that's your c. That's our a, b, and c. Now, we're going to plug these values into this equation. So everywhere you see an a, we're going to replace it with a 1. Everywhere you see b, we're going to replace it with negative 10. And everywhere you see c, we're going to replace it with 21. So first it says negative b. So that's going to be negative. And then what's our value for b? Well, our value for b is negative 10. So we're going to have a double negative there. That's going to make it positive. But notice this first negative comes from the quadratic function itself. And then the second negative comes from the fact that b is negative. Okay. But then plus or minus So always put those plus and minus there. Square root. And then here it's b squared. So that's going to be, what's our b value? That's negative 10. So that's negative 10 squared. Okay. Minus 4 times a, right, times a, well, that's 1 in our case, times c. 4 times a times c. 4 times a times c. C is 21 in our case. All divided by 2 times a. Again, a is 1. So negative negative 10, that makes positive 10. Okay. Plus or minus square root. And then we're going to start working out what this is. So first, negative 10 squared, that means negative 10 times negative 10. That's positive 100. Negative 4 times 1 times 21. That's negative 84. All over 2 times 1, which is 2. Okay, so yeah, we're just kind of working out what this is, and we're just going to work it out a little bit at a time. Okay, kind of using the order of operations. So now what we're going to do is let's figure out what's in the square root here. So 100 minus 84, well, that's 16. So we have 10 plus or minus the square root of 16 over 2. Okay, so 100 minus 84, that's 16. Now, what's the square root of 16? In other words, what number times itself gives you 16? What number times itself gives you 16? Hopefully you know that that's 4. So the square root of 16, that's 4. So it becomes 10 plus or minus 4 over 2. All right. Now, here's where I kind of split it into two different answers. So there's a 10 plus 4 over 2, and then there's a 10 minus 4 over 2. So there's a 10. That plus or minus basically splits into two different answers. So 10 plus 4 over 2, and then the other one was 10, I wrote that a little too big here, 10 minus 4 over 2. So that plus or minus splits into two different answers here. So this becomes 10 plus 4. Okay, that's 14 over 2. All right, that's 7. Okay, so 7, that's one of our answers. Then the other one, 10 minus 4, that's 6 over 2. Okay, that's 3. And now we have our two answers. So our answers are 7 and 3. Okay. Now, what did we just find? What's interesting about these numbers that we just found? Well, these tell you the x-intercepts. So if you were to graph this function, if you were to graph that function, it would cross the x-axis at these two locations. So if you were to graph it, it would make a parabola that crosses at the x-axis at 3 and 7. Okay, and that's basically what it tells you. Okay, question 5. An astronaut on the moon throws a baseball upward. The height of the ball in feet, y, is related to the number of seconds since the ball was thrown, x. And then we have this equation, y equals negative 2.7x squared plus 30x plus 6.5. How high will the ball be after 3 seconds? Use your calculator to pull up a function table to help you. All right, you don't need a function table, you don't need that. But to figure out the height after 3 seconds, what you'd want to do is you want to replace the x value with 3. Because remember, it talks about the number of seconds since the ball was thrown. So the amount of time is x in this one. So in our case, after 3 seconds, so our x value is 3. So what you're going to do is going to replace the x value with 3. Okay. there's not much room to write this work, but I'm going to try to write it over here on the left. So it's going to be y equals, and I'm going to write this equation, but I'm going to replace the x with 3. So that's negative 2.7 x squared, so that's going to become 3 squared, plus 30x, so that's 30 times x, so 30 times, and the x value is 3. Again, just replacing the x with 3, plus 6.5. Okay, just rewriting the equation, replacing everywhere you see an x with 3. So this becomes negative 2.7, 3 squared, that's 9, right? Remember, 3 squared, that means 3 times 3. Plus 30 times 3, well, that's 90, plus 6.5. Oh, I put a decimal in the wrong spot. 6.5. All right. Now, negative 2.7 times 9. Use my calculator here. 2.7 times 9. So that's going to be negative 24.3. Plus 90 plus 6.5. I'll go ahead and combine those. So that's plus 96.5. All right, so I've got negative 24.3 plus 96.5. Okay, calculator says that that's 72.2. Okay, there we go. So after 3 seconds, the ball will have a height of 72.2 feet. So this next one is quite a bit tougher, but it says give the approximate times in seconds that the ball will be a height of 75 feet. So here they're giving you the height. Now remember, in this equation, the height is actually the y value. So we're going to replace y with 75. Okay, so so this is for part A here. Part A. I'm going to do part B here. Part B might be here and down here. So basically, you're going to rewrite this equation, but now we're going to replace y with 75. Now notice there are 2 answers here. It says this many seconds on its way up, and then this many seconds on its way down. Now the reason for that is because you can imagine the ball being thrown. It gets thrown up, and then it comes back down. And we want to know at what time, so this axis is time, at what time does it reach a height of 75? So let's say this is a height of 75. So there's actually 2 times where that happens. It happens right here, and we need to find what time that happens. And then it happens here. We need to figure out what time that happens. So on its way up, it hits 75 feet height, and then on its way down, it hits 75 feet height. So there's actually 2 times where that happens, and we need to find those 2 times. So we're going to go ahead and rewrite this equation, and we're going to replace y, the height, with 75. So this becomes 75 equals negative 2.7 x squared plus 30x plus 6.5. And we need to find the x value. The first thing I would do is, see how it has 75 here on the left? We actually don't want that. We want it to be 0 over here on the left. So we're going to go ahead and subtract 75 over here. And that way we'll get 0 on this side of the equal sign. Now, of course, if we subtract 75 on this side, we have to subtract 75 on the right side as well. Okay, and you're just going to go ahead and subtract it with the constant because these are both constants, and we'll subtract those together. So that becomes 0. 75 minus 75 is 0. equals negative 2.7 x squared plus 30x, and then 6.5 minus 75 is negative 68.5. Okay. All right, I hope that makes sense so far. Again, I'm just making a 0 over here on the left side. Now from here, we're going to use that quadratic formula. That's the formula we used right here. So we're going to use this formula again. Okay. So in this case, our A, again, our A is whatever's next to the x squared. So in our case, the A is negative 2.7. The B is whatever's next to the x. So in our case, the B is 30. And the C is our constant, which in our case is negative 68.5. And we're going to be using the quadratic formula. I'm going to go ahead and write it over here just to remind ourselves. So that's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Yes, you have to have that memorized. Okay, so everywhere you see an a, we're going to replace it with negative 2.7. Everywhere you see a b, we're going to replace it with 30. And everywhere you see a c, we're going to replace it with negative 68.5. So that's going to be negative b, so that's 30, negative b, plus or minus the square root of b squared, so that's going to be 30 squared, minus 4 times a, that's 2.7, that's ugly, times c, negative 68.5. All over 2 times a. So 2 times negative 2.7. Okay, so we'd have negative 30. Right, negative 30 plus or minus square root. All right, so what's 30 squared? That's 900. Then negative 4 times negative 2.7 times negative 68.5. So that's going to be negative 739.8. Over 2 times negative 2.7. That's going to be negative 5.4. Okay, so that's going to be negative 30 plus or minus square root. And let's go ahead and combine those. So 900 minus 739.8, which is 160.2. All over negative 5.4. Let's do the square root of this 160.2. So that's going to be negative 30 plus or minus. So in your calculator, you're going to want to do the square root of 160.2. So square root of 160.2. Okay. Make sure you know how to use your calculator to find the square root. All right. And a lot of calculators, you have to press like the second button and then press the x squared. You can see there's like a green square root above that. Lots of calculators, you have to do that sort of thing. Make sure you can get the answer 12.66 is what I got, rounding to the second decimal place. Okay, make sure you're able to get that value on your own. Okay, you're going to need to be able to do that on the test. Okay, and then here's where we split it into two. So the first one is, I guess I'll write them down here. First one is negative 30 plus 12.66 over negative 5.4. And the other one has the minus, right? So negative 30 minus 12.66 over negative 5.4. Okay. So let's go ahead and do this one. So negative 30 plus 12.66, that gives me negative 17.34. And then we're going to divide by negative 5.4. So that gives us a negative divided by negative, that's positive, 3.21. And then the second one, so this negative 30 minus 12.66, that's negative 42.66. And then we're going to divide that by negative 5.4. Which gives us 7.9. And again, it should be positive because a negative divided by a negative gives you positive. All right, so the first time it reaches that height is after 3.21 seconds. And the second time it reaches that height is after 7.9 seconds. So on its way up, it takes 3.21 seconds, and then it has a height of 75. And then back on its way down, after 7.9 seconds, it has that height again, 75. Okay, that last one was pretty tough. Okay, but hopefully you were able to get through it. Okay, well with that, if you followed along, and I hope it all made sense, you were able to hopefully at least pass everything on this review. If you have any more questions, you could always email me. My email is ttrigg@ofy.org. Okay, well with that, good luck on the test, and I'll see you next time.